Good evening, everyone. What I want to do today is work on the power supply for these GMRS radios. I've had these on here before. I got these for the great price of nothing, and I bought a set of batteries for them. I'll link the video on it that I did on this before. The way the batteries work is interesting, and that's mostly what I talked about there. When I got them, the reason I got them for nothing is because they didn't charge. And the reason they didn't charge is because the charger that was hooked up to it, well, I'll show you on the back of this. The power here to these things is 9 volts, which makes sense, and it's center positive. And I think the power supply that was hooked up to these originally was 5 volt center negative, which didn't work. Or maybe it was 5 volt center positive, can't remember. Anyway, I have a 9 volt power supply. This is, actually, judging by its weight and the fact that the voltage does pop up a bit, this is a linear supply, 7 watts. This is a pretty beefy 9 volt power supply. Quite good, like that. So we've got a working power supply, and here's the right size plug, and here is, I just, used one of these female adapters just to get it through. So we know which is the positive and which is the negative, and we know that for this, but we'll double check with the multimeter. So what I wanted to do today is get out some heat shrink sleeving. I've got the soldering iron over here warming up. We've got the thick solder, well, that'll be fine for this purpose. And I want to solder this through so we've got a working power supply to charge these things. I've got to say, I find the batteries get warm in these when they sit on the charger, and that makes me a bit nervous, so I don't tend to leave them on the charger. If they're modern nickel metal hydrides, they don't need to be charged all the time. So I tend to unplug this when it's not being used. And that might, part of that might be the voltage going up in this, but I doubt it. I haven't looked inside this because it's got irritating screws, although I bet I do have a screwdriver that would work in those, but I'm sure there is some power limiting going on in here. So, yeah. So, let me get a meter out, we'll push this stuff out of the way, and we'll go ahead and solder up this cable. We'll be back in just a moment. All right, so now what we want to do is we want to plug this in and turn on the meter. We'll put the meter back in. Oh, get it into view again. So I plugged it in, and we should be able to check what the voltage is on that. And you'll see it's popped up a bit, right? 17 volts for a 9 volt power supply. But that's because there's no load on this, and this is a linear supply. So now we should be able to plug it in here, put these on. And as you can see, they happily charge. And if you were to check the voltage on that, I'm sure it will have gone down to 9 volts because it's a linear power supply, and that's what they do. Now let's have a look inside this charger circuit. And the other thing we can do is take out the meter and have a look and see what kind of regulation we've got on the power supply inside here. So this is using star screws, I think, which will not fit those. Those are too big. This one, it's usually the one in the middle. Oh, that's right. So fortunately I have these. We've got 4 screws. So let's open this up, have a look at what's inside. I never noticed it's got a little On the bottom it says light on for charging. I mean, I guess the concern is if the power supply here drifts up too much, that you could end up overcharging the batteries. But of course, that if it's, and that would depend on whether there is anything inside here. So what do we got? We have two LEDs. We've got two charging ports. We've got a single diode. We have the position for a capacitor, which is not installed. Two capacitors, one for each phone. We have the charging lugs come down and are spring connected to these, and then come up, and then we have the sort of nickel or whatever they are, steel connectors here. So let's have a look at this board and see what happens with it. Comes in. This lug is just being used to support the plug. It's not doing anything. This looks like the shield coming around, and that would go into, yeah, so that would go into the negative side of the capacitor. We have the positive coming around here, going through the diode. So there is, that's going to give some drop. And goes through the diode and gets connected directly to this side. And there's a bridge here. It's marked R2, but it's just got a wire in it, which is coming around here and going into this side here. I'm not Big Clive, but I did try to sketch out what the circuit looks like for this. So we've got positive, negative coming in, and that's 9 volt nominal. There's a diode, that's this diode, D1. There are two resistors. There's an 100 ohm resistor, which is coming in, goes through the LED. This is the battery, positive, minus, right? So that's the battery that's being charged. So current has to flow through the battery or the resistor won't light. There's the other side of the resistor is the 68 ohm. So that forms the voltage divider to get the 2 point whatever volts to drive the LED here. And this is just duplicated for the two sides of the circuit. There's only one diode, but everything else is duplicated. So you can go down and then you would have the same thing here, right? With a second battery like that. So that's the two sides of the circuit. So it's fairly straightforward. Now the question is, of course, what the voltages are on this and whether they rise to something that's inappropriate if the because of the power supply. So I'm trying to figure out how to do this, and one of the things that we could do is I just have this on continuity at the moment. One of the irritations of the Handtech as a continuity meter is that it likes to do that. On the other hand, you hear it. So these are tied together These are not. Why are those not? Oh, because they're running through these resistors, right? Yeah. Well, what I'm going to do first is I'm going to plug it in, and we'll look at some of the voltages on this with no load on it. Then I think I'll put it back together and see if I can somehow squeeze figure out some way of, you know what I'll probably do is I'll attach this here like this. Yeah. I'll hold that in place like that, and then we'll put the batteries on it and see if I can somehow manage to measure some things around the back of this. All right, so let's do that. So keep in mind that there are 2 cells in the battery pack. So that means the battery packs are going to charge up to about 6 volts. Sorry, what am I saying? Charge up to about 3 volts, thereabouts. The nickel metal hydride, but you usually push them a little bit more. So let's see what we see on the voltage between these. 16 volts. Well, that's a bit. So unsurprisingly, the full voltage of the power supply is creeping up. We should see voltage drop along the diode. Okay, we should see. Of about 5 volts, right? Negative if you do it the other way around. Huh. What are we getting? Oh, yeah. 0.9 volts along the diode. Okay, so let me try pushing this back into its case here, like this. I'll try to line up the LEDs, like that. I'll try to do that on camera a little bit. What I do is line up these LEDs so that they hook into their appropriate spots. And I'll plug that in. And I'm going to get a reach over behind me in just a moment and get a radio, and we'll see what happens. I have a radio now, and I'm holding this in place, and if I do that, it starts to charge. I'm just wondering if I can somehow manage to see what the voltage is on here. So we're trying to see the voltage between the 2 charging lugs, which is going to be here and here. So 5 volts. Okay, can we see what it is across the, just out of curiosity, across here, the LED. Oops. Won't be anything because I'm not managing to hold it on. You know what? Do it down here, it'd be easier to get onto. .9, that seems reasonable. So the voltage on the batteries is fairly high. I'm going to get a second radio and see if I can manage to do it with 2 radios in place. But just before we do that, I had a quick look at the battery pack just to see if I'd misremembered what it looked like. And as you can see, it's a 3-cell battery pack, right? 3 cells in there, 3 cells if you put your own AAA's in there. So it's 4.5 volts, not 3 volts. Yep, that's wrong. This is all wrong. Wrong. Okay, so let's find the plug. Let's plug this back in. Let's put the meter back on DC volts. Let me just, do I have the camera on still? Yeah. Let me just, all right. Let's just bend this up a little bit so that I can clip onto it more effectively. All right. Well, that's the blue one. That's the 68 ohm resistor. And let's set this back in here. So we've got a 68 ohm resistor, and I want to look at voltage drop. I've scratched up the back of that board. Okay. All right. Oh, where'd the plug go? There it is in my lap. Okay, so we'll plug that in. .5 volts. So that's the voltage drop across the 68 ohm resistor. What's the voltage drop across the 100 ohm resistor? Do the same thing. Bend those up just a little bit. That's going to go right over here anyway. And 4.7 volts. So across the 100 ohm, it's 4.7 volts. That is what I just saw, isn't it? I'll just do that again. Ah, 2.7 volts. That's more like it. All right. 2.7 volts. Okay, so now we can calculate the current correctly, as opposed to what I was doing. So V equals IR. We'll do it twice, and then we'll just add up the currents. I think that'll work. So 6.5 equals I. The resistance there is 68. So I is equal to 6.5 divided by 68. And for the other one, we've got the same thing. We've got 2.7 equals I and 100 ohms. So that's supposed to be EI. So we have I is equal to 2.7 divided by 100. And I will get a scientific calculator this time. Let's reach up here. I'll have to take off the microphone. Reach up here. Better calculator choice. Okay, so we want to do 6.5 divided by 68 equals, and we get 0.096. So we'll say, not surprising, so we'll say 96 milliamps there. And we'll clear 2.7 divided by 100. We don't really need a calculator for this, but we will do. And that gives us 0.027. So that's 27 milliamps, right? So clear. So 96 plus 27 equals 123 milliamps. So that's total 123 milliamps. That's a lot to go through AAA batteries. So I think the reality is that this power supply is probably a poor choice for use with this because the voltage is inadequately regulated. I'm probably still going to continue using it in that you'll charge it up, charge the batteries, and then unplug it almost immediately as soon as they're charged. I think that's what I'm going to continue doing, but really a better power supply would be a good choice. Now I kind of want to measure it. Okay. So how are we going to measure it? I'm going to measure it by splitting this cord. Well, first let's put this back together so that we can do everything a little bit more easily. And I have that the wrong way around. So there we go. LEDs lined up. So it's just a question of putting these 4 little screws in. And we'll get the appropriate screwdriver. So is my back of the envelope calculation here of the current going to be correct or not? It'll be interesting to find out. Okay, so what I'm going to do is I'm going to take this cable, reach over here, sorry for the noise of the chair moving around, and I'm going to just use an X-Acto knife and split the 2 sides together apart. I mean, like that. That's ugly, but that's okay. And then I'm going to find the other meter. And this has a DC clamp. So this has a DC clamp meter function. So we'll set this to 2 amps. And select DC. Now, one of the problems with this little unity meter is that holding 0 is an issue, and it's not going to be very accurate at this relatively low current numbers, but it will be good enough for this purpose. So let's plug it in. So we should see that's 220 milliamps. Well, that's the ballpark of 123. Here, I'll move this over here so we can see it. The ballpark was 123 per, And of course, when you've got 2 on, the voltage is dropped lower. Let's take 1 off. 141. So this calculation is right in the ballpark for what it's drawing. And we'll just see, yeah, zeros, you know, always drifts on this thing, especially when you have other electronics around it. But 200 milliamps, 100 per battery pack. I mean, it doesn't make me super happy. I think I'm fine with using it that way as long as I remember to unplug it afterward, because it'll cook these battery packs fairly quickly. But I think the reality is that a different power supply would be a better choice for charging these things. So hopefully you've enjoyed this little look at the making a charging cable and then deciding that maybe this isn't the best power supply to use for these little radios. Thanks for watching.